Check. Yeah, sounds like this is working. So it's really good to see so many people turn up just before lunch for a talk on French absurdist literature. So, but it's about code. So this is a talk that is inspired by a movement in French literature that consisted of writers, but also mathematicians and people interested in logic and things like that. This basically translates to workshop of potential code. And I got the idea for this talk when I came across this book by Georges Perec, La Disparition, or Avoid as its English translated volume's title is. It's a 300-page novel written entirely without using the letter E. And the letter E is the most commonly used letter in the French language. It looks like this. For those of you who can read French, this is actually very readable, and it's a marvelous feat to be able to write something like this without using the most common letter. And this got me thinking, what would this look like if we applied it to programming languages? And take away the most common features of our languages. So this is a bit of very familiar C# code. This is the classic FISBUS thing, which relies very much on the keyword if. And I would suggest that conditional ifs are the most common keyword in most programming languages. So I sat down and figured, let's try to write FISBUS without using if. And the thing I came up with was this. So this uses a switch statement and pattern matching to achieve the same thing. And to be honest, I think this code is actually quite elegant. So by applying some restrictions to how I could write code, I came up with a very elegant solution. I also realized that by doing this, I had invented Haskell. Because this is how you would do FISBUS in Haskell. And it's more or less exactly the same solution as my conditional-less C# FISBUS. Here's another book written by one of the famous Oulipo authors. This is one called 100,000 billion poems. And that's actually mathematically correct. It's printed on little strips of paper, so you can sort of turn individual bits of the page. Raymond Queneau, who wrote this, he was a mathematician. And so you have a book filled with endless poems. And this is most likely one of the stupidest examples I have, but I figured about how can we do this with FISBUS? And I came up with the ridiculous idea of just generating random Python source code and running it and seeing what happens. So this is the code for generating the source code for doing one take on FISBUS. There are some lessons to be learned from this as well. You can't really just use the regular random generator in Python because that will repeat the same patterns over and over again. So instead, I had to use a cryptographic hash to be more or less sure that we had unique variations on the source code every time. And then, of course, you would do this. You would loop through all of this, run one of the examples, and just compare the output to see if you got the right one. I did not allow this to run long enough for that to actually happen. Georges Perec, again, User Manual for Life. This is a novel about people living in an apartment building in Paris. And it's more or less a literary puzzle based on the Knight's Tour chess problem. So as you move through the apartment building, it's built around this. Which I found, that might be an interesting thing to play around with, but I wanted to combine it with another book. And this is Raymond Queneau's Exercises in Style. In this book, he tells the same story 99 times. But what he changes from each story to the other is that he uses a different literary style. So some of them are written as plays, some of them as poems, and so forth. So 99 different styles of writing. So let's imagine that we have a 10 by 10, 100 square chessboard, because we are allowed to do that when we experiment with things. And combine these two books and just start off with finding 100 ways to solve the Knight's Tour problem. So for the clever people, this using the Warndorf's heuristic algorithm is the right way to do this. It was specifically designed to solve this problem. So that's the boring thing. We can instead do regular recursion with backtracking, where we sort of explore different paths, and if we get stuck, we backtrack and try something different. Very classic recursion problem. Or we can do something really esoteric. This is the source code for this solved with something called an ant colony optimization. And what you do with that is that you place a load of virtual ants on the chessboard and have them just walk around and leave virtual pheromones behind for the other ants to pick up on, and they will, given enough time, find the most optimal route across the chessboard. Not something that you would use every day. You can use depth-first search. This is probably something that, if anyone here does Advent of Code, you're going to use this a lot. Or you might use the breadth-first search. Or you might do a branch and bound. Or you might do something ridiculous like a genetic algorithm. You might use dynamic programming, although that's not a really good idea. You could do the AI thing and do the Monte Carlo search tree if you want to. There are basically hundreds of ways to solve this particular problem. And that brings us to the question, why on earth am I doing this? Because constraints are often seen as limitations. They are boundaries that box us in, but the writers of the Oulipo movement didn't see it that way. They saw these restrictions as invitations. Invitations to think sideways, to reinvent and surprise themselves. And as programmers, we often aim for perfection, for idiomatic code. But once in a while, if we step outside the comfort zone of our conventions, we create space for discovery. And we find new paths through old problems. We might discover things in the programming languages that we use that we have not ever taken time to learn, or maybe forgotten that we learned in the first place. And through doing so, we make all things new and interesting again. And we can find out what happens in the space between. Thank you all for coming to this strange talk. My name is Anders Norås. I have a world premiere of a brand new talk about one of the pioneers of IT industry later on today. So hope some of you will come to that. Thank you so much for coming.